And hello, my name is Dan Oak and I'm a student at Athabasca University currently taking the course Computer Science 444 Embedded/Robotic Programming. And today I'm going to be talking to you guys about the SparkFun Inventors Kit. If you're currently a student in Comp 444 through Athabasca University, then this guide as well as this kit, the SparkFun Inventors Kit, you will have received with your registration into the course. And it basically takes you through various projects starting off with Arduino from blinking an LED all the way up to making a remote control car. So as I said, I'm going to be taking you through this SparkFun Inventors Guide up to page 35. I was originally going to talk about assembling the red board and a couple of the components of the red board, but the guide does such an amazing job with that. I'm more or less going to just focus on the first project, and specifically that first project is broken up into 4 circuits, as you can see highlighted here in yellow, purple, black, and blue, and we're going to be going through that. So the first circuit, circuit 1A, introduces blinking an LED, which is demonstrating digital output in a simple yet effective way. We will upload code that makes the LED flash on and off, which is a fundamental skill in programming with Arduino. I'll explain key concepts like polarity, the direction of current flow, Ohm's law, which relates voltage, current, and resistance, and the differences between digital and analog signals. Following circuit, and by the way, blinking LED is the quintessential first, code program that you would do when doing Arduino coding. So typically, writing a program to say "Hello World," basically displaying "Hello World" to a console, is the first program that you will write in essentially every language you learn. Okay, it's the first example. Well, blinking LED is the "Hello World" of Arduino. Following that circuit, however, we'll explore circuit 1B, which incorporates a potentiometer to adjust the brightness of an LED, which will enhance our understanding of analog input. And a potentiometer is a variable resistor, and a resistor limits the current through a component. And we're going to be talking about all these things as we go on. In circuit 1C, we're going to introduce a photoresistor, enabling the circuit to respond to changes in light levels, leading to practical applications in sensors. So just as a potentiometer is a variable resistor, something that the user can control via knob or or similar means, photoresistor is a variable resistor, but it's something that's controlled by the light level. And if you have a night light in your house that's plugged in that turns on when the lights get shut off and turns off when you turn on the lights, that would be working off of photoresistor technology. And then finally, in circuit 1D, we're going to create a multicolored RGB nightlight. RGB stands for red, green, blue. And it's going to be controlled by a combination of photoresistor and potentiometer, basically combining the concepts we learned in the previous 2 projects. So that's what we're going to be talking about today. So in the first part of the guide is basically going to show you how to, it's going to talk about the red board, which is a microcontroller. It's a Arduino type microcontroller, a generic microcontroller. And they're going to be talking about all the features associated with the red board, as well as how to assemble the red board on this plastic mount along with a breadboard. And that's basically what it looks like. But I'm not going to be using this for this. I've already got that set up, as you can see, with some other circuitry for something else. And instead, I'm just going to be using another generic Arduino board called the Elegoo board. And you can find these on Amazon for fairly cheap. I think I got this board and this 37 sensor kit on Amazon for maybe $70, $80, something like that. Along with, I bought a couple extra breadboards so I could do some various things. So with that being said, I'm going to go through some of this guide fairly quickly because it's going to talk about things that really you should just read the guide in its entirety. It's a great guide. It does a really good job of explaining things, as does the accompanying website. So I'll go through things quick, and more or less the point of this video is to show you guys a Comp 444 student like yourself completing the first project, specifically the first 4 circuits associated with the project, as well as I've done the coding examples and coding exercises and challenges associated with the first project. So let's go through the guide. So I'm going to go through fairly quickly. When you first get into the guide, basically it tells you what this guide does. So this booklet contains information to build 5 projects, which encompass 16 circuits. We're going to be focusing on the one project today, which incorporates 4 circuits, circuits 1A, 1B, 1C, and 1D. And at the center of this manual is one core philosophy, and that's that anyone can and should play around with electronics. So again, following the table of contents, we're going to be focused on project 1 today, which incorporates these 4 circuits. Circuit 1A, blinking LED, which is the hello world of microcontrollers. Circuit 1B, potentiometer, which is a variable resistor. Circuit 1C, photoresistor, which is another variable type of resistor, but one that we don't control, and rather the resistance is controlled by the light level in the room. And finally, circuit 1D, creating an RGB, that's red, green, blue, nightlight. Then it talks about the red board itself, the platform, which is basically this board here, which again is just a generic Arduino board, which will work the exact same as this Elegoo board that I've got off Amazon. So again, all the pinouts are the same, the functionality, they're identical. So there will be no difference between what I'm explaining, using, and applying to this, as would be done on this red board. Now, it does, I've got a couple things highlighted here. I'll just mention those quickly. The SparkFun Redboard Quick, which I'm just going to say Redboard from now on for short, is a development board. It's essentially a small portable computer known as a microcontroller, capable of taking inputs, like the push of a button or reading a sensor, and then interpreting that information and then controlling various outputs, like blinking an LED or spinning an electric motor. This is a way of doing physical computing. So this board is capable of taking the world of electronics and relating it to the physical world, i.e. by lighting something up or moving motors, which, actuators which attach to arms, and various other things. This red board, as well as the Elegoo board that I'm using, and many Arduino boards, is based off the Atmega 328 microprocessor. And the microprocessor associated with a development board such as the red board or the Elegoo board that I'm using is basically, it is the brains of the whole microcontroller. So the whole microcontroller is fairly large, but really all the work is being done by this little Atmega 328 chip, which both the Elegoo is based off of and the red board is based off of. And all of the other things, so like, you can see there's a fair bit of empty space on the development board here where the name is, and they have other things in here, but this, like these pinout areas, this is just, ultimately inside the circuitry, inside the board here, connected to these pinouts that you kind of see here, these little pins here. So, and a lot of the other stuff, like being able to hook up external power so we can control external things like motors and different stuff, and all the capacitors and all of the other electronics associated with the development board are extras and nice, and they allow you to conveniently breadboard a development board and get started with it right away. But at the end of the day, all the work is really being done by the chips, which you could breadboard separately and do all the work just via the chips. So that's basically how development boards work. They basically make it easy to start with electronics, but as you become more familiar, you can end up just moving on straight to programming and controlling these chips directly. But that's beyond the scope of this course. But other things associated with the red board, or any of the Arduino boards for that matter, there's 14 digital input and output pins, so pins 0 to 13. There's 6 analog pins denoted with A, 0 through 5 here, and it has a 16 megahertz crystal oscillator for its clock. All the next pages basically about assembling the breadboard on the plastic mount with the breadboard. See, redboard and breadboard are confusing me saying them quickly here. And then the next pages here show the red board and just basically highlight what the different things are. So A here is your barrel jack that can be used with either 9 volts or 12 volts. Lets you know what the digital input pins, the analog pins, power pins. Basically just go through this and it'll explain everything associated with the red board that you need to understand. And again, the red board is going to be identical with the Elegoo board or an Arduino board that I'm using here that you're going to get off Amazon. Then it talks about the breadboard if you're not used to that. It does go into the Arduino IDE, how to download it and how to use it. Again, I'm going to skip that because it's all done very well in the guide. Basically, I just will highlight here, if you're not familiar with Arduino or the IDE, the Integrated Development Environment, it's essentially like a word processor for coding. So just like a word processor, you don't need a word processor to type something. You just type it in like in Notepad or any text editor, but you don't have a lot of features. You don't have all the spell check features or all the formatting features to make your font look nice and all that sort of thing. Well, it's similar to any programming IDE, and in particular the Arduino IDE that we're talking about here. You could just write code in any sort of text editor and accomplish the same thing, but the integrated development environment makes it a lot easier, and it has like so-called spell check in the sense that it will help you avoid syntax errors and has auto completion and debugging. So definitely want to go and download that. You're also going to need to install some USB drivers for use with the SparkFun board itself, the red board. And let's get right to the code, which is what we were supposed to be doing from the start here. This is all the components that come with the kit. And now let's get started with our first circuit. So, as you can see, the first circuit, the first project rather, is broken up into 4 different parts, A through D. First part being blinking LED, then reading a potentiometer, then reading a photoresistor, and finally creating that RGB nightlight. So in project 1, we're going to be learning about light emitting diodes, resistors, inputs, outputs, and sensors, as well as the nightlight, which uses a sensor to turn on an RGB red, green, blue LED. We're also going to change the color using an input knob, a potentiometer. So the components that we're going to be introduced in this project are LEDs, resistors, which limit current flow, potentiometers, which are variable resistors that we control via like a knob, and then photoresistors, which are another type of variable resistor, but something that we don't directly control, but rather the resistance of a photoresistor is controlled by the light level in the room. And then we're going to be discussing these concepts: polarity, Ohm's law, digital output, analog versus digital, analog input, analog to digital conversion, voltage divider, pulse width modulation, and functions. So let's get started. So again, the first circuit, 1A, is blinking an LED. It is the hello world of microcontrollers, the first project you would do. And in this project, all you need is a simple LED, a 330 ohm resistor, and 2 jumper wires. So the new components we're going to be discussing here are a light emitting diode, LEDs, which are just small lights made from a silicone diode. They come in different colors, brightnesses, and sizes, and are all just, but they're pronounced LEDs for short, for light emitting diode. And they have a positive leg and a negative leg, and you can see that over here in the diagram, that they do have, the positive leg is longer and has this little bend in it typically, and then the negative leg is a lot shorter. And the reason for the positive negative leg is they only let electricity flow them in one direction, which means they're polarized. We'll talk about that in a minute. And when you're using a light emitting diode, it's important to always use a resistor with them. And that will limit the current through the wire going to the LED in the circuit. So again, resistors resist the flow of electricity, and they basically protect sensitive components like LEDs. And the strength of a resistor is measured in ohms, which is marked on the body of the resistor. And typically, because resistors are so small, they're marked with a color-coded system. So again, the resistors I have in the circuit here, which came in the kit I bought, but they would also come in the SparkFun kit, have these little colored bands that you can't really tell from here, but that the colored bands are just so that you can actually tell what the resistance is without measuring it with a multimeter. A couple other concepts that are new concepts for this project are polarity, which is basically when electricity is able to flow through something in one direction, like an LED, which is why an LED has positive and negative legs. Resistors, on the other hand, do not have polarity, so electricity can flow through them in any direction. So again, in electronics, some components are polarized, meaning electricity can only flow through them in one way, like an LED and other diodes. And then some are non-polarized, electricity can flow through them in any way, like a resistor. Then Ohm's law we're going to discuss, which basically describes the relationship between these three fundamental elements of electricity, namely voltage, resistance, and current. And it's shown in this relationship. Voltage equals current times resistance. And obviously for any of our math aficionados out there who are really good with rearranging formulas, if you know two of these variables, you can figure out the third. So as we can see here, voltage is equal to current times resistance, but we could just as well divide both sides by current, which is denoted by I, and we would see that resistance is equal to voltage divided by current, or we could have divided both sides by R and found out that current is equal to voltage divided by resistance. Basically, it just shows that voltage is directly proportional to current and resistance. So if you increase the current and or the resistance, or both, you'll increase the voltage. And similarly, if you decrease the current or the resistance, or both, the voltage will be decreased. And as I explained, if we were to rearrange this formula by dividing both sides by current, let's say, we'd have R equals V over I, and we'd see that resistance is inversely proportional to current. Or if we had divided both sides by I, R, we would see that current is equals to voltage divided by resistance, and we'd see that current and resistance are both inversely proportional. I understand that's probably hard to see without me having a computer capable of drawing that and showing you, so I'll try to do that right now. So what I was saying there was, we can tell from this that voltage is equal to current times resistance, and that basically just shows us that if you increase either current or resistance or both, because of the relationship here, this is a product, the voltage is going to go up. So current is directly proportional to voltage, as is resistance is directly proportional to voltage, meaning whatever you do to current, increase or decrease it, you're going to do the same to voltage. If you increase the current, you're going to increase the voltage. Decrease the current, you're going to decrease the voltage. And the same holds true for resistance. Increasing it will increase the voltage, decreasing it will decrease the voltage. Whereas if I was to rearrange this formula and divide both sides by, let's say, I would have R equals V over I. So now resistance, and if you didn't see how that's done, when you divide both sides by I, this cancels out because anything divided by itself is 1, which 1 times anything is that thing, so resistance equals voltage over current. So resistance equals voltage over current, and this basically shows that, again, as we denoted before, resistance and voltage are directly proportional. Increasing one will increase the other, or decreasing one will decrease the other. But the relationship between resistance and current is that of an inverse relationship. So if you were to increase current, you would actually decrease the resistance. And if you were to decrease current, you would increase the resistance. And the reason being is because where the current is in the denominator, if you have a larger denominator, if you increase the denominator, you have an overall smaller number. An example would be shown if I have 1 over 1, well, that's 1. Then if I have 1 over 2, meaning I've increased the denominator, well, half is smaller than 1. So by increasing the denominator, I've made the overall number smaller. And 1/100th, increasing the bottom number by a lot, I've made the whole number really small. 1/100th is a lot smaller than 1 or 1/2. And the same would hold true if I had current equals voltage over resistance. Same thing, they're inversely proportional. So whatever you do to one, the opposite will happen to the other. That was a little bit of a side tangent, I apologize. But really, that's what Ohm's law states. It just basically relates voltage, current, and resistance. And this equation is used to calculate what resistor values are suitable to sufficiently limit the current flowing through an LED. So if you want to find out the exact LED value you should have, you can look up and see what the voltage drop, how much voltage an LED uses, and then find out the resistor that you need to use. Although for all intents and practical purposes in this course, using like a 330 ohm resistor for all of your LEDs will be sufficient. But if you want to know the exact values, you can do the calculations. It talks about the digital output here. So digital output, there are 14 pins, and a digital output only has two states, on or off, high or low, true or false. This shows a resistor that is a polarized component, meaning it has a negative side and a positive side. The negative side has a shorter lag than the positive side. Also, on the resistor, there's a flat edge on the actual LED bulb itself on the negative side. These are just a couple things that help denote the side, what the negative from the positive is. The resistor leads, again, resistors, this just shows how to bend them and fit them in the breadboard, but resistors are not polarized, so there's no positive and negative side. You can plug them in either way and they'll work. So this is the hookup guide associated with Project 1, Part A. Basically, you're just hooking up a LED, and one of the ends needs to go through a resistor. In this case, it's the positive lead that's hooked into a resistor, which gets hooked into one of the digital pins, and the negative lead gets hooked into ground. Again, this resistor could have just as well been on this side going to ground, and the positive lead could have had no resistor. It's as long as the resistor is in the circuit. So it doesn't really matter what it's in, if it's on the negative lead or the positive lead. This just explains how the circuit diagrams work in this guide. And then you're going to go to the examples, and yeah, you're going to go to the examples, and that came with the guide, and came if you went online to the SparkFun Inventors Kit Guide Master. You're going to go there and you're going to be able to load the code up without actually writing it, and then hook up the circuit and test it out right away and get started. So the overview of program circuit 1A is just you're going to turn the LED on by sending power 5 volts to digital pin 13. You're going to wait 2 seconds or 2000 milliseconds, as the delay function that's used takes in milliseconds as a parameter, and then you're going to turn the LED off by cutting the power to 0 volts to digital pin 13. Wait 2 more milliseconds and repeat. The onboard LED is hooked up to digital pin 13, and there's one on almost any Arduino or Arduino compatible board, and this LED is connected to digital pin 13, the onboard LED. The code associated with circuit 1A is this, and I'm just realizing this video is quite long, a lot longer than I thought, and I'm actually just getting into Project 1A. So what I'm going to do is I'm going to end the video here. And basically, I guess this video will just be me having kind of laid out what we're going to do here, which is going through the SparkFun Inventors Kit. I mentioned a little bit about the SparkFun board here and the various components, digital output, and that sort of thing. But I'm going to actually end the video here, and I'm going to come up with a new video starting actually doing the project, so people can move on from me talking.